Hello and welcome to our trace lesson. Our trace lesson is about alkenes, but before we are going to see our trace lesson, let's take you back what we have seen in our last discussion. That was about chemical property of alkene and its isomerical structure. So, if you have any doubt regarding our last discussion, please put in our comment section, and you should have to, visit my Telegram channel. Thank you very much for today. So today we are going to about alkene. What is alkene? Alkene is one of these carbon-carbon triple bond, which we call it unsaturated hydrocarbons. One of the part of hydrocarbon, which have three triple bond, or we call it carbon-carbon triple bond. Under alkane, we have a general formula CnH2n minus of 2. Alkenes are homologous series, also called acetylene series. Their homologous series are called acetylene series. Examples of alkenes are when n is equal to 2, because n is starting from 2, from the general formula of alkane, n is started from 2, and then when n is equal to, let's apply it in general formula, C2H2 times 2 minus of 2. Here it is a short note about this lesson. And so let's take three examples of alkane by applying the general formula CnH2n minus of 2 in order to make homologous series or acetylene series. So when n is equal to 2, then apply the general formula C2H2 times 2 minus of 2. This one is 4 minus of 2, which is C2H2. We call it acetylene. And the second one, when n is equal to 3, then let's apply it 3 C3. Instead of n, we are substituting 3, then 2 times 3 is 6, 6 minus of 2, which is equal to 4. And when n is equal to 4, let's make it C is equal to 4, 2 times 4 minus of 2, n is equal to 2. I mean, this molecular formula of the given example is C4H6. This is, we call it totally from n is equal to up to n is equal to 4. Homologous series, because they have the same consecutive difference. If we make applying the second number, the largest number minus the smallest number, our result is the same for all these homologous series of alkene. With if we are applying the general formula of CnH2n minus of 2. So let's see next about nomenclature of alkene, how to naming nomenclature of alkene. You know, here we have two important things when we make nomenclature or naming alkanes or hydrocarbon compound by the two methods. The first one is common name. For the simplest saturated or acetyl hydrocarbon, we have a common name. This common names of this alkane, we have three examples how to make naming this alkanes. Let's look at here. We have a detailed structure of acetylene, hydrogen, triple bond, carbon, triple bond, carbon, hydrogen. This is, we call it, its common name is acetylene. And the second one is here we have HC, triple bond, carbon, CH3. There are two different molecules here. One is CH3 and here is hydrogen. Therefore, we call it methyl acetyl. And the second one is CH3, carbon, triple bond, carbon, CH3. There are two, the same with a different position, the same molecule, but alkyl molecule, but they have what? Different positions. Therefore, we call them dimethyl acetyl. This is the common name, and this one is, we call it their common names. How to name their common name. And the last one, we call it about ibacnine. as you have said before, we have two systems of naming. The first one is a common name, and the second one is IBAC name. This IBAC name is, as you have so in our last discussion, it is an international agreement which used to be read for all organic compounds, because for especially for this complex organic compounds are using naming by the IBAC name, International Union Pure and Applied Chemistry. You see, so we have followed the same rules as we have follow in carbon-carbon single bond and double bond, but here we always starting nearest to the triple bond. We always started to nearest the end of double bond. From the double bond, from the triple bond, we always starting from the nearest triple bond, and almost they have the same principles we are applying here, but the only difference is we should have to always starting from the nearest double bond, as triple bond, as we have do in double bond. We always starting from the nearest double bond, also here we are applying nearest triple bond. Therefore, let's have an example. Here we have five carbon atoms, and we have a side chains. Here we have two side chains, because our longest chain is already known, so we always prefer to starting from the longest chain one. Here we have, because a triple bond, 1, 2, 3, 4, 5. You see, here there are 5 carbon atoms, and here we have two side chains. The side chains, one is methyl, the other one is ethyl. Therefore, 3 ethyl, which because it's alphabetical, E is come before M. Therefore, 3 ethyl and 3 methyl, because they are at the same position. Then we call them 3, 3, but their molecules are different. This one is methyl and this one is ethyl. Then 3 ethyl, 3 methyl, 1 pentyl. 1 indicates the position of triple bond, and pentyl indicates the parental structure of the given molecule. And next we are going to see about isomerism alkene. Isomerisms of alkene. As you have in carbon-carbon double bond and triple bond, here we also applying isomerism. So isomer means the same mass, but different what? Different structural arrangement. This application also applied in a triple bond. Then alkenes exist. Shows some structural and positional isomers, but they don't show any cis-trans isomers or geometric isomers are not applying the triple bonds. The most common isomers carbons are the lowest member homologous series of alkane or carbon-carbon triples are not follow, not show any isomerical structure, because they have what? They are so simple. These are ethyl and propyls don't show in any kind of isomeric property. But this carbon atom increasing, their isomerism structure also increasing. Let's see an example. Here we have example CH3, CH2, carbon double bond CH. We call it 1 butane, to indicate the position of the triple bond. And second example is CH3, CH, triple bond CH, CH3. This we call it 2 butane. Look, the same molecule, but their positions are different, because here as the first is carbon atom. The triple bond is located at the first, and here at the middle. Located at what? At the middle. This is the position of isomers of butane, C4, H8. So this is enough for today. If you have any doubt, please visit my Telegram channel, and directly you can ask me by put in my comment section. And as I have told you last time, please join and make your own teaching, learning online for making your ability to help your those who have not addressing education. Thank you very much.